Welcome back for another example on the payout annuity formula. In this example, you want to be able to withdraw $25,000 each year for 15 years, and your account pays 5% interest. A, how much do you need in your account at the beginning? B, how much total money will you pull out of the account? And C, how much of that money is interest? So here's the payout annuity formula. Let's review what these variables represent. P sub 0 is the balance in the account at the beginning, also called the starting amount or principal. D is the regular withdrawal amount, or the amount you take out each time period. R is the annual interest rate expressed as a decimal. K is the number of compounding periods in 1 year, and N is the number of years withdrawals are made. The compounding frequency is not always explicitly given, but is determined by how often you take the withdrawals. So going back to our example, let's identify all of the given information. Well, first you want to withdraw $25,000 each year, which means D would be equal to 25,000, but also tells us K, the number of compounds per year, equals 1, since the withdrawal is made one time each year. So K is equal to 1. The withdrawals are made over 15 years, which means N is equal to 15. And the account earns 5% interest, so R is equal to 5%, which must be expressed as a decimal, which would be 0.05. To answer part A, how much do you need in the account at the beginning, we need to find P sub 0. So for the next step, we'll perform substitution into the payout annuity formula. So we'll substitute 25,000 for D, which is here. We'll substitute 1 for K, which is here, here, and here. We'll substitute 15 for N. And finally, we'll substitute 0.05 for R, which is here and here. Now if we evaluate this, we can determine P sub 0, how much you need in the account at the beginning. So now we'll go to the calculator. Let's evaluate inside the parentheses here in the numerator. Notice how our denominator is just going to be 0.05 because we're dividing by 1. So let's go ahead and evaluate this expression here in the numerator in the parentheses. So we'd have 1 minus the quantity 1 plus, again here we're just dividing by 1, so that's going to be plus 0.05, close parenthesis. We're going to raise this to the power of, we can see, would be negative 15. Again, when rounding, we should include at least 3 significant digits, but notice here I'm including all the decimal places. So now to find P sub 0, we want to find this product in the numerator and then divide by 0.05. So in the numerator we would have 25,000, which I'll put in parentheses, times 0.518, 982, 9019, and we're going to divide this product by 0.05. To the nearest cent, notice that P sub 0 is $259,491.45, which is our answer to part A, how much you need in the account at the beginning. So if you have this much money in the account at the beginning, you'd be able to withdraw $25,000 each year for 15 years, as long as the account earns 5%. Part B asked, how much total money will you pull out of the account? Well, you're going to be withdrawing $25,000 once a year for 15 years. So for part B, we would take $25,000 and multiply by 15, which gives a total of $375,000 withdrawn from the account over the 15 years. So this would be part B. So if we go back to part A just for a second, notice how the starting balance has to be this amount, but over the 15 years, you actually withdraw $375,000. So the last part, part C, how much of that money is interest? Well, the interest earned would be the difference between the amount taken out of the account here and the starting account balance. So again, the interest earned would be $375,000 minus $259,491.45, which gives a difference of $115,508.55. This is how much interest is earned over the 15 years. And that's it for this example. I hope you found this helpful.